multiplying rational expressions. So we just reviewed multiplying fractions, right? But let's do that in the video as well. You did it on your homework last night. If we have two fractions, something like 6/10 times 25/4, how do we multiply those? There's two ways, as we just saw. So the first way would be just multiply the two things in the top. 6 times 25. Multiply the two things in the bottom. 4 times 10. So this is 150 over 40. Is that right?
Yeah.
Yep. And then we could then cancel here. What factors do these have in common? Well, they both have a 10. So that would give us 15 over 4. This is not how I would multiply fractions personally, but you can do it this way. What I would do is actually look before I multiply to see if there are any common factors between the top and the bottom. So for example, I know that 6 and 10 both have a 2 in them. So I would cancel that first. And then I see that 25 and 5 both have a 5 in them. So then I would cancel that. And then I'm just going to multiply 3 times 5 is 15, and 1 times 4 is 4. I get the same answer. I just think this is a little bit easier to cancel your factors before you multiply them. You deal with smaller numbers overall.
Yeah, why didn't the 4 get?
Well, I could have canceled like the 6 with the 4, but the way it is now, 3 and 5 don't have any factors in common with 4. So I can't cancel the 4 with anything right now. Right? Sometimes there are different ways, right? Like in this problem, I could have canceled a 2 from here and here. Oops, that would be 3, and that would be 2. I could have done it that way. And then I could have canceled a 5 from here and here. And I would have ended up with 3 times 5 and 2 times 2. The same answer. I'm just looking for any factor that is common between any part of the top and any part of the bottom. So with rational expressions, we're going to do the same thing. It's just that sometimes our factors are more complicated. So let's start out with sort of a simple example. What if I had something like this? We've actually already done this type of problem. How would we simplify this? Yeah, we would cancel an x from the bottom and 1x from the top. So we would have 3x squared over 2. So we can cancel variables as well as numbers. And in fact, we can not only cancel variables and numbers, we can cancel entire expressions. So if I had 2x plus 3 over 5 times 3 over 2x plus 3, I can actually cancel the 2x plus 3 with the 2x plus 3. Because it's a factor in the top and it's a factor in the bottom. One way to think about this is numerators and denominators always have parentheses around them. There's like an invisible parentheses here. So we're kind of looking for things that are inside parentheses in a way. A really important mistake, and sometimes I hesitate to even point this out, because then I'm afraid people will make the mistake, because I've shown it to you. You can't cancel this 3 with this 3. Why not?
Because this 2x plus 3 is part of that.
Yeah, this 3 is part of the 2x plus 3. It's not on its own anywhere, right? It's not a factor. So I can't just cancel the 3 because it's part of the 2x. It's like 2x plus 3 is together. So in this problem, I would cancel the entire 2x plus 3, and I would end up with 3/5 x cannot equal negative 3x. What would be my excluded value in this problem up here?
Negative 2 over 3x squared.
My excluded value, what could x not be equal to?
Negative x?
What would make this denominator 0? 0. So in this problem, the only excluded value is 0 itself. And that's going to happen when you don't have x plus, you just have x kind of sitting there by itself. Alright. So we're multiplying rational expressions. This is really not that much different from what we've been doing. It's actually very similar to simplifying rational expressions. It's just now we have two fractions at the beginning and we combine them into one fraction. Right? So I might have something like this. X squared plus 6x plus 9 over 7x plus 7 times x plus 1 over x squared minus 9, sorry. So essentially, the way that I think about these is, this is the same thing as simplifying rational expressions. I'm not really going to multiply until the very end. The first thing I'm going to do is factor the tops, factor the bottoms, and look for something to cancel between the top and bottom. It's just now I have, instead of like before, we would have just had this part, right? We would have just had one fraction. Now I've got two fractions. So I have a total of 1, 2, 3, 4 things that I'm looking to factor. I'm going to factor the numerator in the first fraction, the denominator in the first fraction, the numerator in the second fraction, and the denominator in the second fraction. So 1, 2, 3, 4 different factoring problems. Then I cancel, then I combine. Okay, so let's write that out. Step 1, factor everything. Okay, so how do I factor x squared plus 6x plus 9? That would be x plus 3 times x plus 3. You guys agree? Okay. Can I factor 7x plus 7?
Yeah.
7 parentheses x plus 1. Times, can I factor x plus 1?
No.
No, there's nothing I can do with x plus 1, right? There's no way to factor that. Can I factor x squared minus 9?
X plus 3 is minus 3.
X plus 3, x minus 3.
Wait, so would you have one more than the 2 excluded values in this one?
Yeah.
Okay.
In this one we're going to have 3 excluded values.
Okay.
Step 2, cancel. Factors.
2x plus 3.
Okay, so there's an x plus 3 here and an x plus 3 there. I can cancel that with that.
Then the x plus 1.
There's an x plus 1 here and an x plus 1 here.
Yeah.
I can cancel those.
And now it's simplified.
And that's it. That's all that I could cancel. So I've got x plus 3 over 7 times 1 over x minus 3.
Then you have to multiply.
And then I multiply.
Then it's going to be plus 3 over 7x minus 21.
Yeah, x plus 3 times 1 is x plus 3. And then I would leave this factored probably. Just leave it like that. You could distribute this to have 7x minus 21. It wouldn't be wrong if you did that. Okay. And then step 4
Oh, I see one.
is excluded values, right? So what are my excluded values?
Negative 1.
Okay, so negative 1 from this factor,
-3.
negative 3 from this factor, and 3 from this factor. So my answer is x plus 3 over 7 times x minus 3. X cannot equal negative 1, negative 3, or 3. Alright, let's do another example. I'm going to erase these steps, and you can tell me from your notes what I should do next. Alright, let's say we had this. X squared 5x 4 over x squared plus 6x 5 times x squared plus 7x. Oops, sorry. I wanted that to be in the bottom. X squared plus 7x 12, and then the top x squared plus 3x. Okay, so what's my first step? What am I going to try to do? Factor everything. So can we factor this? What would it be? X plus 1 and x plus 4. Okay, can I factor this?
X plus 5, x plus 1.
X plus 5, x plus 1. Can I factor this?
No.
Factors of 1 that add up to 3.
You can plot an X.
Oh,
Yeah,
+2 and
there's actually really no way to factor that, right?
Yeah.
We could try to think of things. Positive 2 and negative 1, that doesn't add up to 3, and it also doesn't multiply to 1. There's only 2 factors of 1 and 1, and they don't add up to 3. Right? Yeah, or negative 1 and negative 1. And neither way do they add up to 3. We could check that it doesn't factor by plugging in the discriminant and figuring out how many solutions there are. But I think you can, at this point, you can probably just trust your intuition. Right? If something doesn't factor, you'll know it. There's no factors of 1 that add up to 3. It just isn't possible.
The next one is 3 and 4.
So we just leave it the same. That's fine. It just sits there. And then this one, x plus 3, x plus 4. What am I going to do next?
You can cancel the 2x plus 4s.
Okay, so I can cancel the x plus 4s. These are up top and down bottom. And I can cancel the x plus 1s. So notice it doesn't really matter if I cancel the top here and the bottom here, or the top here and the bottom there. I'm basically already ignoring this. I'm just thinking of this as one big fraction. Right? It's kind of natural to just like immediately, you don't even really need the time sign. You have one big fraction and you're multiplying everything. Right? Okay, so then the trick is, what do I have left? What's left up top?
1.
This, right? X squared plus 3x plus 1, exactly. And what's left down bottom? X plus 5 and x plus 3. Am I done? What do I do next?
Could you add those 2 on the bottom?
Well, we wouldn't add them. We could FOIL them.
Yeah.
We don't need to. You could. It'd be totally fine if you did.
Oh, discriminate.
Find the excluded values, right? X cannot equal
-4, -1.
negative 4, negative 1,
3,
negative 3, or negative 5.
Oh, that's a lot.
Right?
Wait, so those are just like if you plug those in, it'll be 0?
Right.
Okay.
The denominator would equal 0. can't have a denominator.
Which means it wouldn't even happen.
Now, sometimes you'll see things that look a little funny, right? So let's do some examples. Like, I mean, we could have things that maybe we don't think we know how to factor. Like this. 9r to the 7th plus r to the 5th over 3x squared plus 2x plus 4x to the 5th plus actually 12x to the 5th plus 8x to the 4th times, I'm just trying to think of something totally crazy, right? So then maybe we've got over here, we've got like 3x plus 2, and down here x squared.
You can't factor the R, right?
Oh, sorry. I started with r. Let's make them all r. I'm so used to x. Okay, so what if they were all r?
Well, from the top, could you take out 5r?
Okay, so in the top, that looks kind of weird. It's got like r to the 7th, but yeah, I'm just looking
R
for
to the 5th.
basically
Plus
the greatest
9
common
r
factor.
squared plus.
So I would pull out r to the 5th, and then I would have 9r squared plus 1. Can I factor this?
9. Yeah. No.
The correct answer is no, right? Because we learned about a difference of squares, like 9r squared minus 1 we could factor, but you can never factor a sum of squares.
Couldn't you do that thing where you cross out the 3 and it turns into 1, but then you cross out the 9 and it turns into 3, so it's 3r to the 7th plus r to the 5th?
No. You have to factor. You can only cancel factors. Right?
No,
We
you know
can-
that thing with the never mind, I don't think that works.
Well, we have to factor first, and then
Can
we'll
we change
see.
that 3r to a...
How are we going to factor? I'm giving you a big hint. How are we going to factor something if we have 4 terms?
Here.
Yeah, try to take something out of the first two. What did we call this? Factoring by grouping, right? So what could I factor out of the first two? R
And out of the second, we can factor 4.
plus, I could factor 4
R to the 4th.
R to the 4th,
And then you get 3r plus 2.
and then, I'm actually not done. I would not write this. I would write 3r plus 2
R plus 4
to the 4th. So we can factor this. I mean, it's kind of weird, like, I don't really know what to do with this next. There's all these big coefficients on r. Can we factor this?
No.
Yeah, you can. With the 3r plus 2 on the bottom of the...
We can cancel it, yeah. But we can't really factor it.
But we can cancel
Can you cancel r squared? I mean, can you factor r squared?
Yeah.
You could take out an r. and
Technically,
make r times
it's r times r, right? But we probably would just kind of see that in our heads.
It's R times R, you should just take
So
that
what
out.
factors do I now have in common between the top and the bottom?
3r plus 2.
The 3r plus 2, that can cancel. And there actually is another one here.
What's it?
Yo, you gotta take that like.
What is it? R squared?
Yeah, I can cancel r squared here and r squared here.
Oh.
What's left here?
R to the 3rd.
R to the 3rd. Right? So look for those kinds of canceling opportunities, because like we said, we don't usually actually factor r squared, but it is r times r, and we could cancel those two r's and two commas here.
But if you did make that r times r, couldn't you
No,
take out the top r and
No,
3r?
because it's in like remember it's like kind of in parentheses.
Wait,
It's like
from
part
where?
of the
And it's 3r plus 2 and r to the second. If you factor out the r squared.
No! No!
Yeah, no.
Remember, we cannot factor terms. I can't cancel this with this because this is not a factor. This is, but this whole thing together makes one factor.
Oh, so down here would have to be 3r plus 2r.
Right. 3r plus 2. So I'm looking for that factor all together. The reason I can cancel it from here is there's no plus anything attached to this, right? This is a factor in itself. It's not r to the 5th plus 1. So I can cancel r's. Does that make sense? Okay. So what do I have left? Up top I've got r to the 3rd, and then 9r squared plus 1. Down bottom I've got
r plus 4 to the 4th.
yeah. I'm actually going to write it the other way. 4r to the 4th plus r. It's the same thing. We just typically would write the bigger exponent first.
Then it'll just be the same.
What are my excluded values? R cannot be.
Negative 2 over 3r. Negative r squared.
Yeah, what would make this be 0?
Oh, negative r over 4r. 4? Or just 0? Yeah, just 0, right?
Yeah.
0 would definitely make it 0. We can solve it, right? 4r to the 4th plus r equals 0.
Maybe
So the trick to solving this is to recognize that if I divided by r, I would have 4r to the 3rd plus 1. And then I would have negative minus 1 on both sides. And then I would divide by 4. And then I would take the cubed root to get rid of that cube. So technically one of my factors is, one of my excluded values is the cube root of negative 1/4.
Oh geez, that's too
Now I will say that typically if you get to something this complicated in rational expressions, they're not also going to ask you for the excluded value.
Is that what's in there?
So yeah, on your homework they actually don't ask you for the excluded values. So this homework, right, on the entire homework. So that's to simplify the expression. On this homework they're going to focus more on simplifying weird things and not as much on excluded value. So something like this, you typically wouldn't see these together at this level of algebra. Yeah.
When would you use excluded values in real life?
So
When you become a math
when you teach 8th grade algebra classes, that's when I use it.
Yeah.
I would say, I don't know the exact applications of this in real life, but what I do know is that in terms of looking at more advanced functions, right? So eventually you're going to be graphing things that look similar to this. You're going to be graphing in algebra 2. You're going to be graphing sort of rational functions, right? And in order to do that, you need to have some understanding of how to simplify rational expressions, right? So it's partly leading up to stuff that you'll see later on. And then I do know also that, if in terms of, if you were to develop models of most things that happen in the real world, a lot of things don't fall into the really simple type of algebra that we've seen up until now. So what we're developing are the tools to model more complex things, right? So I'm gonna do my homework tonight of looking up and finding what would be a specific example for something like a rational expression. But I do know that in terms of the way things work in the real world, sometimes it falls into these weird patterns
And then sometimes it's just
that
the tools that will
you
help
wouldn't.
you later, like.
Right.
I have a question.
Yeah.
Okay. So, I think that just like we learn all like the basic math tools and stuff like that, but then I think that I think that you should just like, because most people, unless you want to be like a scientist or a mathematician, you won't usually use like a lot of like the math that you learn. I guess like you
Totally.
could, but I think.
Or a teacher.
Yeah. Yeah, I think you should like learn like the basics of like science and math and stuff like that, but then you should like do other things.
Okay, I'll say two things about that. The first thing is, I think that there's more and more people that are starting to agree with you, and they actually right now are currently looking at restructuring the way that math is taught in high school, which would then affect middle school.
Like no,
So they are looking at that. People are looking at that. The other thing though is, I do think that there's something to be said for learning hard things. Because part of the reason you're in school is to learn how to learn. You know what I mean? And so if we only taught you easy things, and you only ever learned to learn easy things, right? Then you wouldn't just develop that skill of perseverance, right? Of keeping track of complicated, like in this case, right? Keeping track of complicated sets of things. And whether you use that in math, or whether you just use that as a skill in life, right? When whatever career you go into, there are going to be more advanced things for you to learn. So there is something to be said for just kind of sticking with it and learning things that are tougher.
I feel like that totally makes sense. I think that everything that we're learning right now, this like needs to be learned so that we can make better decisions like in life and like when we're older. I guess.
Sure.
But I also think that we should, okay, so like we just learn like all this stuff